Hello, this is section 5.6 exponential and logarithmic equation. So exponential function, exponential equation, so equation in which one or more variable occur in the exponent of the expression is called the exponential equation. So we are using the power rule for the to solving the exponential equation in here. Okay, so example one. The population P of Arizona has been increasing annual rate of 2.3%. So in 2010, the population of the Arizona was 6.4 million. So write a formula for the P of X, where the X is a year of the P is in million. So the population for the Arizona, which is 2010 was 6.4 million. So I skipped I'm not using the million. I'm just gonna use a million for the units, and then 2.3% same as 1.023, and as but x. But if I just put the x, so zero means a zero year, but it's starting from the 2010, so I will subtract the 2010. So in 2010 becomes a zero, and then 2001 becomes 2011 becomes one. All right, so now I'm gonna find out the estimate the population of the Arizona in 2000. Actually, this must be a 14. Okay, this is typo errors. So yeah, because we don't want looking for the past. Okay, so f of 2014, which is 6.4, and then 1.023 to the power of 2014 subtract 2010. Oh, sorry. 2010, which is, if you use a calculator, it's about the 7 years. 7 million, sorry. Okay. All right, next page. So when light passes through a water, its intensity I decreases according to the formula I of x equal to I sub 0 times e to the negative kx, where I sub 0 is the initial intensity of the light and x is the depth in feet. And if I of x 500 times e to the negative 0.2x power determine the symbolically the depth of x at which the intensity I is 1% of I sub 0 equal to 500. So um, I want to say I of x, which that's the formula that is. Okay, so in order to actually find it, we need to find that as 0.01 of the 500, which becomes a 5. Okay, so I of x as a formula because of 500 the initial intensity, and then times by e to the k is a negative 0.2 to the x. Okay, so I of x is a 5, and then 500 e to the negative 0.2x, and then we are solving for x, so divide by 500 both sides. I got the 0.01 to get e to the negative 0.2x, and then you can put the ln both sides, and then you get the ln of 0.01, and this becomes negative 0.2x, and divide by negative 0.2 both sides, and then you get x equal to 23.03. Okay, so which means the lining intensity is 1% of I sub 0 500 at about the 23.03 feet deep. So it's about feet, it's about feet deep. Okay. And example 3, the concentration of the drug in a patient's bloodstream after T hours is modeled by formula C of T equal to 11 times 0.72t. Oh, so this must be a power t. Sorry, but that's a typo error too. Where C is the measure in milligram per liter. So what is the initial concentration of the drug? So C of t equal to 11 times 0.72 to the tth power. But initial value means t is a 0. So 11 of 0.72 to the 0 power equal to 11. Now B, how long does it take for the concentration decreases to 50% of the initial level? So the initial was 11. To be a 50% of the 11 becomes 5.5 of the 0.72 to the tth power, and then we are solving for t. So I want to divide by 11 both sides. Oh, sorry about that. So divide by 11 both sides. Then I get 0.5 equal to the 0.72 to the tth power, and put the ln of 0.5 equal to ln of 0.72 to the tth power, which is same as ln 5 equal to t times ln of 0.72. So divide by ln 0.72 both sides, and then it becomes t is gonna be the 2.11, which is that's the there'll be the should be the hours, right? So it's hours. Okay. Yeah, because they usually, yeah, t is hours. Yeah, so should be the hours. Okay, so next page. Now we are solving the exponential equation. So I need to check that out the two ways. Okay, if the base is the same or base is different. So this is the base is the same, which is 9 and 9 base both sides, right? So you can just say 2x equal to 4 minus x to solve for x. So adding x to the sides, 3x equal to 4 divided by 3. So answer is a 4 thirds. For the second one, okay, we need to isolate the exponents, the base of the exponent first. Okay, so we got 6 times 1.3 to the x power equal to 24. And then divide by 6 both sides, I got 1.3 to the x power equal to 4. And then I put the ln both sides of 1.3x. That's the way you can pull the x down as a factor. And then becomes x ln 1.3 equal to 1.4. And then divide by ln 1.3 both sides. Ln 1.3 both sides. And then x equal to about the 5.284. Alright, let us see. Okay, this one bases not matching each other, so I'm just gonna put the you can just log with the base 10 too. So half of 1 minus x of log of 1 over 7. Now you can pull that down in 1 minus x of log of half equal to log of 1 over 7. And then you can divide by log of half both sides. And then I got 1 minus x that equal to log of 1/7 divided by log of half. And then it is actually the subtracting -1 both sides. And then negative x equal to the log of 1/7 divided by log of 1/2 minus 1. And then multiply by -1 both sides, I get the 1 minus log of 1/7 over log of 1/2, which is about negative 1.807. All right, the last one for this example, okay, so 4 and 3, there's no way we can match the base, so I just put the log of ln both sides. So I use ln this. Oh, sorry. So ln of 4 to the 3x power, ln of 3 to the x minus 1. And you can pull out the 3x ln 4 of x minus ln 3. And then This time your x is on the left and the right too. So 3x ln 4. And then distribute the ln 3 for x ln 3 minus ln 3. And then you need to put the x term together in one side. And then I got factor out the x as a 3 ln 4 minus ln 3 equal to negative ln 3. And then divide by 3 ln 4 by minus ln 3 both sides. And then you get the oh sorry, there's a mistake I made. I'm sorry about that. Yeah, I just forgot that there was a 2. Sorry about that. So there was 2, right? So this is 2, this is 2. And the distributor is going to be 2 ln 3. So this must be stay as 2 ln 3. Of course, here. Sorry about that. And then when you use a calculator on this one, you get about the negative 0.718. Okay, alrighty. Sorry about that. Alright, next page. Now we are solving this equation. Of course, you can use ln both sides, but this time, actually, what I see is I can change the base 9 and 27 as 3. So 9 is a 3 squared to the x plus 5 power, and 27 is a 3 cube of 3x. So this is 3 to the 2 times x plus 5, and then 3 to the 3 times 3x. Which means now you can say 2 times 3x, 2 times x plus 5 equal to 9x. And then 2x plus 10 equal to 9x. Subtract 2x both sides. 10 equal to 7x and divide by 7. And then x is equal to the 10/7, okay? All right. Now, let's look at the example 6. A pot of the coffee with a temperature of the 90 degree is set down in a room with a temperature of the 25 degree. The coffee cools to 60 degree after 1 hour. Find the value of the T sub 0, D, and A, so that the T of T equal to T sub 0 plus D times A to T model of the data. Okay, so the room temperature has a T sub 0 equal to as a 25. Okay, so T sub 0 that I can use as and 25 degree. And then the initial temperature difference between the coffee and the room is, which is then represent the D. So you have to subtract to the 90 degree, subtract the 25 degree, which makes a 65 degree. All right, so that's a D. So if you're gonna plug it in, of the T of T is equal to 25 plus 65 A to the Tth power. Now we have to find the A, but in order to find the A, I have to use the coffee cools the 60 degree after 1 hour. So T of 1 and 25 plus 65 A to the T. But T of 1 is the same as 60. 60. So 60 equal to 25 plus 65 A to the T. And subtract 25 both sides. I got 35, which is a 65 A to the T divided by 65. And then A to the T equal to the 7/13. And then T is a 1. What am I talking about here? Sorry about that. T of 1, because T of 1 that you're using it. So A is a 7/13. So we got the full equation. So now your T of T is 25 as a T sub 0, 65 as a D, A is a 7/13 to the Tth power. So that's what you're looking for. Now, to find the temperature of the coffee after half hour, now we can find it. So half hours from 65, 7/13. Now T is a 1/2. Use a calculator. I get the 72.7 degree. Celsius, of course. How long did it take for the coffee to reach the 50 degree? So now T of T equal to the 25 plus 65 to the 713 to the tth power, but t of t is actually we want to make a 50 degree, which is a 25 plus 65 t 713 to t, and then we're solving for t, so subtract 25 both sides, so 25 equal to 65 times 713 to the t divided by 65. I got 513 to the 713 to the t power, and then put the log both sides, 513, and then log of 713 t, and then which is you can putting down the t in the front as a t is equal to the log of 513 over log of 713, which come out as 1.54. So that hours, okay. So the temperature of the coffee reaches the 50 degree after 1.54 hours. Okay, now the logarithmic function. Now, the logarithm function contains a logarithm. To solve the logarithmic equation, we use the inverse property. So, which is this is called inverse property. Okay. So we are solving for 4 log of the 5 2x equal to 6. So first of all, I need you to divide by 4. You can cancel the 4 from the left. And 2 of x equal to 3 over 2. And then we want to change to the exponential equation. So which is the base of 5 exponent 3 over 2 equal to 2x. And then we just need to divide by 2. And then your x is 5 to the 3 over 2 power over 2. So it is about 5.59. Okay, number 8. Solve each equation. So same thing too. So we're going to change the exponential equation. So base of 2 to the power 3 equal to 4x minus 2. And then we're solving for x, which is 8 plus 2. And then 10 equal to 4x. And then divide by 4. X equals 5 over 2. Okay, in here, which is, I want to actually combine all the term with the log on one side. So I got log of 20x plus log of x, which is equal to 5. And then the sum of two log becomes a product. So 20x times x equal to 5. And change the exponential equation. So base 10 to the 5th power of the 20x squared. And then divide by 20, which becomes 5,000 equal to the x squared. And then x is going to be the square root of 5,000. And then simplify x as 50 over equal to. Okay? But I can't take the negative though, because if I put the negative, it's going to be plus minus actually. But I cannot take the negative because negative log doesn't exist. Log of the negative does not exist, okay? All right, let's look at the next page. Now, what if you have a log on both sides? That's the case is you need to put as ln of x plus 1. But first of all, I need to pull the x minus 1 as a square. And then you got the ln both sides. You can pull out as x plus 1 is the same as x minus 1 squared. So x plus 1 is same as x squared plus 2x plus 1. Subtract x both sides, subtract 1 both sides. And then 0 equal to x squared minus 3x, which is 0 equal to x times x minus 3. So you have x equal to 0, x equal to 3. But x equal to 0 doesn't exist because when you put the 0 here, it becomes ln of, 0 here. 0 minus 1, which is ln negative 1, is undefined. So we can't use that, but we are okay with the 3 though. Alright, now exponential logarithmic inequality. So if the inequality sign in exponential logarithmic equation is replaced with less than or greater, less than equal to or greater equal to, or exponential inequality or logarithmic inequality results. Many times it helps to us use our understanding of exponential logarithmic functions and their graphs to solve these types of the inequalities. The fact that the inequalities are often boundary between greater than or less than is helpful to determining the solution set. So let's solving the inequality problem here. So first of all, Of course, you need to add 1 both sides. So you got 2 to the e to the n equal to 2. And then divide by 2 both sides is going to be equal to 1. And then put the ln both sides. And then it's going to be x, but ln 1 is a 0. So this is it. But you need to write the interval notation, which means everything has to be greater than 0 or equal to. So that's the interval notation. Alright, so that's for the how to solving the exponential and then the logarithm equation. Thank you for listening.